Good morning, everyone. I just want to talk about the hydrogen bond again. For example, in water molecule, okay, this is oxygen. Oxygen is 2.6, 1, 2, 3, 4, 5, and 6. All right, and this is hydrogen. Okay, they share one pair of electrons. This is hydrogen. So you can see that after the sharing of electrons, oxygen becomes 2.8, and electron arrangement for hydrogen becomes 2, 1, 2. Okay, so this is covalent bond. Right, covalent bond. Over here is single covalent bond because one pair of electrons shared, and then over here another covalent bond, right, because of the one pair of electrons shared. So single covalent bond, there are two single covalent bonds. So that's covalent bond. Now this green line here, this is covalent bond. Okay, the thing is now, because this oxygen atom is very electronegative. Alright, so this oxygen is very electronegative. Now when it's very electronegative, electronegative means the ability for the atom to pull electrons to itself. Okay, so let me draw a simpler model. Okay, I'll draw here. This is oxygen. Okay, and then we have hydrogen and hydrogen. Okay, this is the covalent bond. Alright, so because oxygen is very electronegative, so it has a higher tendency to pull the electrons to itself. So that means to say the sharing, right? The sharing of electrons here is not equal sharing now. That means it's not like, oh, you take half, I take half. It's not equal sharing. Because of the electronegativity of oxygen, the electrons here actually is closer to the O. Because this O atom has higher tendency to pull the electrons to itself. Alright, so the electrons is actually nearer to O than to H, although they are sharing the electrons. So when the electrons are nearer to O, that makes O slightly more negative. So we call that a partial negative. Okay, a little bit more negative. And because the electron is nearer to O, okay, they're sharing. Electrons are nearer to O, so this H, it makes it slightly positive. Okay, slightly positive. And this is also slightly positive. Okay, let me say that again. Now, electrons are shared, okay, between O and H. Right, it's shared, covalent bond. But because of the nature of O, which is very electronegative, therefore it will have a higher tendency to pull the electrons nearer to itself, although they are still sharing, but you know, it's somewhat stronger, more electronegative. So it will pull the electron nearer to itself. Therefore, it becomes partially negative. And because electrons are further away from H, so this H part here becomes partially positive. Okay, so this is what we call polar. Now, when that happens, okay, when in water it's not just one molecule. Okay, there will be, let's say in this container of water, okay, there will be a lot of other water molecules, and all the other water molecules are also polar. Okay, all the other water molecules are also polar. Right, because of the tendency of O, more electronegative, pull in the electrons. So this O becomes slightly negative, and this H becomes slightly positive, and this slightly positive. So you see, what happens is, you see there is positive and there is negative. Okay, so then there will be, like over here, let's say, okay, this is O, and then there is H and H. Okay, so you see what happens. This is a covalent bond. So this is slightly negative, and this is slightly positive, and this is slightly positive. Okay, so now let's see. This is slightly positive, and this is slightly negative. So there will be an attraction between this slightly positive with this slightly negative. Positive and negative. Now this is called the hydrogen bond. Okay. Hydrogen bond can only happen between a hydrogen and a very electronegative atom. For example, nitrogen, oxygen, and fluorine. Okay, so that is hydrogen bond.